I hope you're able to see the screen.
Yes, sir.
Yeah. This is the time, this is the current, right? X-axis is the current. Now, the motor current. Motor current will be how much in the starting? In the starting current will be how much? 4, 5, 6 times, right? So let's say this is one. Starting current should be somewhere here, right? Current. Now this will be the damage curve, right? Damage curve. That is, this is the let's say this is the damage curve of any equipment. Now, at starting, the motor current will be somewhere here, maybe 6 times. Let's say time versus current. Hmm. So the starting curve of the motor will be something like a chair. Are you able to see this? Are you able to see this? Pinaki?
Yes, sir. Yes, sir. I can see this.
Yeah. So you can see this current, this is the normal current. Okay. This is the starting current. You see the starting current is, let's say, 6 times. Okay. And it starts at, let's say, t equal to 0, and it will be there up to certain time. T is equal to, let's say, what will be the starting time, Mr. Pinaki?
Maybe 4 seconds or something.
Okay, 4 seconds.
Just guessing. Not
Okay,
sure.
guess, no problem. You can guess and I will write down that. Okay. And it will start, and then it will, this is the starting current, this is the running current. So then there is a transition from starting to running. So after the transition take place, it will run normally. So this curve will come like this. So now, how do you determine this starting current? Mr. Vijay,
It will be given, depends on the method of starting, and it is given in motor data sheet.
okay, depends on method of starting and given in the data sheet. Yes, absolutely correct. Now, you are right. Method of starting, why it will depend on method of starting? That also I will tell you. If you draw our speed torque curve, something speed torque curve will be like this, right? This is the speed torque curve, like this. I think this is torque, this is speed, and you can see the bottom one is the load curve, the top is the motor curve. Now this one, the in between, whatever is there, This is the motor accelerating curve. Means this is motor torque Tm minus load torque TL is the accelerating torque. Okay, the black hash portion. And it is this accelerating torque which actually accelerates the motor. Okay. Now, when you change the method of starting, basically what happens, we are playing with this actually. Okay, we are going to make this something like this. So basically the torque will reduce when you change. As the torque reduces, what happens? The time taken increases to start. So suppose here, let's say I reduce my voltage, then what will happen? My starting current, instead of being 6 times, it will become, let's say, 3 times. When the starting current becomes 3 times, it will take more time to start. Okay, so it will be here. The curve will become like this. So you see here the black color curve. Suppose I reduce my starting current further, my curve will become like this. Able to see this? Okay. So, Mr. Naveen Kumar,
Yes, sir.
yeah. So, is this clear? The starting current at different voltages?
Yes, sir. Yes.
Yeah. So when the starting current reduces, the time increases. Why? Because of this curve. Okay. The motor torque minus load torque. What happens when the voltage reduces? Motor torque reduces. When motor torque reduces, what happens? The amount of accelerating torque required increases for a longer duration. That is why. Okay. And how do we get this load torque? Load torque is given by the vendors. Okay.
Okay, sir.
Okay. Thank you. Any doubts you had there in that?
No, sir.
Mm.
Very clear.
Okay. Okay. So now let me go to this PPT. See able to see my. Okay. Now we are able to see this screen PPT.
Yes, sir.
Yes,
We're
sir.
seeing it.
Okay. So you see the inrush current, I told you 4 to 7 times. And the starting time I have explained how it depends on the torque. This hold on. As you change the type of starter, see what are the different types of starting? Mr. Lognathan sir.
Yes, sir. Morning, sir.
Good morning, sir. What are the different
Uh,
types of starting we can use?
One is direct online
Yeah,
starter and star delta starter is mentioned there.
yeah,
VFD and soft starters.
correct.
I remember one more transformer starter, sir. I think they.
Correct. Transformer also is there. Then there is one more, like some flux compensated. Lot of them are there. You are correct.
Okay.
So now all these different methods, basically, they are manipulating the voltage. And in case of VFD, even the frequency is manipulated. Now, what happens when the voltage gets manipulated is the torque will vary, and as the motor torque changes, the starting time. That I have explained. I hope that is clear how the motor torque affects the starting torque. What is the this one in VFD? In case of VFD, what is the starting current? Any
For 2.5 times, sir.
how much?
2.5 times.
and a half.
2.5 times what you would get, sir.
Okay, two
The
and a
full
half.
load current.
Okay, so then naturally the starting time should be more no, in VFD. But in case of VFD, there is change in frequency also, right?
Yes, sir.
Okay, so that V by F ratio will remain same.
V by F ratio will remain same, but they use pulse width modulation, but you'll get 2.5 times the starting current, sir.
Okay, okay, okay. Okay, see now whatever I explained, same thing. This is a motor speed torque curve and this is a load curve. The load curve will be different for compressor, different for fan, different loads will have different curve. And you can get it from the vendor. Okay, the vendor will give it. I have taken this from a Singapore vendor. This curve. The link is here. Later on, you can see that link. I will just paste that link in the WhatsApp group also. Later on, you can go through that window. Okay, now let us come to an example of how to determine the speed torque curve. I will give you first the source of this. This one. Are you able to see the screen? Inamulji, able to see the screen? Pinaki, able to see the screen?
So I can
Yes.
see your screen, sir.
Yeah, yeah. Okay, let me actually share with you our ABB. Okay, there is a very nice guide which I have referred, and I will actually share the link. Please go through. ABB drives as a nice guide. Please go through this. Here it gives lot of explanation on speed torque. Okay, and actually I am not asking you to go through this to learn about drives, but the basics of speed torque and all is very good, very nicely explained here. I will share the link also. Please go through. And actually here they have given very how to determine the. If you go to our ABB equation, this side, nicely it has explained how to determine the starting time. Okay. I will explain that, but I just wanted to give you the source of my. I've been referring these ABB guides from a long time, almost from 20 years. And they are very good. They are very nicely prepared. Okay, and one more. So let me. See here actually that equation what I told you other day, no? Power and torque relation. All those is explained here with the ABP side. And the basic, you please go through this without no, this one basic mechanical laws. Go through today this one. This is very important. Actually, whatever the starting time, all those is dependent on this. I want you to go through that. So today I will be taking one example from this one only. That in case you have any doubt, you can go through this guide. Okay, clear? I will share the links in the WhatsApp group. Please go through those guides. I have shared both the links in the WhatsApp group. You can put. Okay. Now let me go back to the presentation. Able to see the screen? Okay.
Yes, sir.
Torque equation. Okay, let me explain a little bit. See what is torque? Mr. Gaurav,
Yes, sir. Good morning.
good morning, good morning. How are you?
Fine, sir.
Okay. Everybody able to see? What are you seeing now? What are you seeing, everybody?
Sheet acceleration times for different speed sections.
No, you are seeing my PPT?
Yes.
Okay. So now you are able to see this Tm minus TL is equal to, able to see this?
Yes, sir.
Yeah, okay.
Yes.
Okay. So what is torque? Torque is equal to this. What is this basically? Torque is nothing but, you remember your college equation. Force is equal to mass into acceleration. You remember, right? In your pre-university, you might have studied force is equal to mass into acceleration. Pinaki, you remember?
Yes, sir. Newton's second law.
Okay, force is equal to mass into acceleration. Similarly, in rotational also, this is instead of force, I will substitute it with torque. Okay, torque is equal to, instead of force, I will make it inertia. Okay, and acceleration will be rotational acceleration, angular acceleration. Okay, so what is acceleration? Velocity by time. Rate of change of velocity is acceleration. Okay, so how do I get this equation? I have explained. Now, what is the force? Force in a motor, it is the torque of the motor minus torque of the load. That I explained in the previous also. Now, that one is equal to mass. What is the mass here? The mass here is the moment of inertia of the motor and moment of inertia of the load. How will you get the moment of inertia of the motor? From the motor data sheet. How will you get the moment of inertia of the load? You have to get it from the uh, pump vendor. You go to the pump data sheet, you will get it. So if anybody are having pump, compressor, fan data sheet, any one of you, please check whether that moment of inertia is mentioned. If yes, please share the data sheet. Okay, we will discuss on that. Okay,
Yes, sir.
yeah. And okay, so force is equal to mass into acceleration, right? So force is nothing but torque, Tm minus TL. Mass is instead of mass, you substitute moment of inertia of the motor and load. And acceleration is nothing but velocity by time, du omega by dt. Okay. Now this equation I will rearrange. Okay, I'm going to rearrange this equation to get this equation. Okay. How? Take delta t here. Okay. I bring my Tm minus TL here. Now Jm plus JL is nothing but J total. What is omega? See, I'll convert omega to n. Okay. This is the angular velocity, and this is the RPM. I will make it to RPS. Okay. So delta omega. Omega is angular frequency. It is nothing but 2 pi the n. Okay. T omega is nothing but 2 pi n. So 2 pi is here, n is here. Since it is in RPM, I will divide by 60 to get RPS. Okay. Mr. Pinaki, clear how I got from this? Are you clear how I got this equation, Mr. Pinaki?
Yes, sir.
Okay, Mr. Naveen Kumar, are you clear how from this equation I got this equation?
Yes, sir.
Huh? No.
Yes, sir. Yes.
Yes, sir. Okay. Loknathan, sir,
Yes, sir. I think I'm clear, sir.
you are
Yeah,
clear.
just rearranging
Okay.
the formula.
Okay. Now, our Gauravji, you are clear how I got the first equation and second equation.
Second equation you have derived from first equation by rearranging the terms, time
Yeah.
taken to the left.
Yes, correct. And first equation, you are clear how we got?
Yes, because yes, first equation is clear.
Okay. So everybody is clear. Fine. So first equation is basically from our physics. Okay. And second equation, as Mr. Gaurav said, is by rearranging. Now, this one delta t, what we are telling here, no? This delta t is just time. See here. See, when we start, you see how we are starting. Starting is happening slowly, right? So that starting at every instant is calculating. So basically, delta t we have to break it down. It is delta t1, t2, t3, t4, like that. Okay. So now, how many of you have gone through the data sheet of compressor, fan, all those things?
What's the
How,
can you
ma-
repeat what you said?
how many of you have gone through the data sheet of compressor, fan?
No.
No. Okay. Okay. So what? Okay. Let me close here, and again I will log in so that the recording will get backed up. Okay. Give me 5 minutes.